classes of this program. Now we're going to present calculus with Carlos Garcia, Rodrigo Ramos, and Alex Diaz. Give an applause, please.
The problem for our project is the following.
A beach ball is thrown upward from a 20-meter high building. Its position function is given as s times t equals minus 5 times squared plus 10 t plus 10. Consider the gravity as minus 10 meters per second squared.
Hi, Mr. Oscar. Good afternoon. Here we're gonna present to you some of the problems of the project. Here we have problem A. What we needed to do in problem A was to calculate the derivative of the position function using limit definition. This is the formula that we used to get the limit definition of the derivative. First, we transferred all the data, then we solved, and then we canceled. Everything divided by h. Here's what we get after solving and canceling the terms that we're able to cancel, and this is our final answer. Now we have problem B. After examining the whole problem, we get to the conclusion that the derivative of the position function at time t is the velocity at time t. Velocity is the slope of the position function at the given time.
Okay, so now we're calculating the derivative of the function that we got on point A.
To derive the limit definition, you have to apply the limit h approaches to 0 to the function f of x plus h minus f of x, everything over h. Then you have to substitute the limit definition of the original function. That will be minus 10 plus t plus h plus 10 minus 10 plus 10, everything over h. Then you will change the function to minus 10t minus 10h plus 10 plus 10t minus 10 and everything over h. Then you have to simplify or eliminate the values in here. So we got minus 10t plus 10 is 0 minus 10h plus 10t is 0. So we simplify this and we got minus 10h over h. And finally we have to also simplify this and we got minus 10, that is the result of the limit definition.
The derivative of the velocity function is the acceleration function, and the acceleration is the slope of the velocity function at time t.
So this is the function that I was explaining, that is acceleration times time equals minus 10.
Now we're going to calculate the position after 1 second. Okay, so in this case, we're going to use the position formula, and we're going to substitute the 1 second in the formula. So actually it's very easy. As we can see here, it's just like substituting 1 second when the time is, and we see it's completely the same, because well, if you multiply times 1, it's the same. So we just add and subtract the values, and after all we can see that that position it's 25 meters at 1 second. Okay, well now we're going to check the velocity of the ball when it was about to hit the ground. So for this we're going to use the position formula that we already know, and we're going to substitute the values that we already have in the general formula. Okay, so in this case, -5 it's A, 10 it's v, and 20 it's c. After substituting and making all the process, we will get two values. The first one is 3.236 seconds, and the second one is negative 1.23. As we can't have a negative time, it's impossible, and then we will use the first one, okay? Then we substitute right here in this formula that we already have of velocity, and we will get as an answer that the velocity when the ball was about to hit the ground was of negative 22.36 meters over second.
Well, that's how you apply calculus to physics. We hope you enjoyed and you learned a lot. Thank you and see you soon.